This is lesson 7.2. We're going to be talking about the properties of parallelograms. But first, let's define a parallelogram. A parallelogram is a quadrilateral, so a four-sided figure with two pairs of opposite sides parallel. So we see that PQ is parallel to RS. Those sides are opposite each other. And then these are parallel, these opposite sides, QR and PS. And we have a little symbol for parallelogram, just like we had a symbol for triangle, and it looks like a little tiny parallelogram. There are properties of parallelograms. The first one is that if a quadrilateral is a parallelogram, then its opposite sides are congruent. So congruent is different from parallel, right? The congruent symbols are dashes. The parallel symbols were triangles. So one does not automatically mean the other, but every parallelogram will also have opposite sides that are congruent. We also have, if a quadrilateral is a parallelogram, then its opposite angles are congruent. So we define the opposite angles as the ones that are across from each other, right? So Q and S are opposite angles, P and R are opposite angles, and they would match. So here we have a little proof for those two properties. So we are given that PQRS is a parallelogram. The definition of a parallelogram says that we have parallel lines. So we could say that PQ is parallel to RS, and we could say that QR is parallel to PS. Right? That's by definition of parallelogram. So now to say that angle PQS, which was here, is congruent to angle RSQ, which was here, that's because we had parallel lines like these. So those are alternate interior angles. We'll use the alternate interior angle theorem. And then we said we're going to use the alternate interior angle theorem again. So if I used these lines instead, I can get these corners. So that would be angle RQS, which is congruent to angle PSQ. Step 5, we have QS is congruent to SQ. So I'm going to get rid of all these, put just the little things back. So we had these angles, we had these angles, and now in step 5 it says QS and SQ, this segment right here. So that's the reflexive property, right? Something's congruent to itself by reflexive. So now my triangles are congruent. These two triangles are congruent to each other, right? A, S, A. So now that I know the two triangles are congruent, I know any of their pieces are congruent. Notice that the P was in the second spot here and the R was in the second spot here. So we know that P matches with R. So that's because corresponding parts of congruent triangles are congruent. And the same thing with my segments. The QP matches the SR, QP with SR, QR with SP. That's also because corresponding parts of congruent triangles are congruent. So the reason these properties work for parallelograms is because we were dealing with parallel lines, which gave us congruent angles, which allowed us to say that triangles are congruent. One more property is that if a quadrilateral is a parallelogram, it's consecutive angles. Consecutive, like this one and this one, would be consecutive angles. Those are supplementary. And that's also because we're dealing with parallel lines. We know that consecutive interior angles were supplementary when we were dealing with parallel lines, and that's what's happening here. So let's first find these measures in this parallelogram. I would take this picture, and before I looked at these, I would say, okay, 15 here, I could put 15 across from it. 8 here, I could put 8 across from it. 68 degrees here, I could put 68 degrees across from it. And now the only thing left is the other two angles. I know consecutive angles, angles that are next to each other, will add to 180. So I could do 180 minus 68 to get 112. So now these remaining angles are each 112 degrees. Now let's answer these. So AD was 8. DC. DC was 15. The measure of angle A was 112 degrees. The measure of angle B was 68 degrees. And the measure of angle C was 112 degrees. Here's a check-in for you to try. Pause now if you'd like. The answers are posted on Classroom. For example 2, I know that opposite sides are the same, so these two sides would be the same. These two sides would be the same, so I know that 18 will equal y plus 3. So if I want y alone, I could take away 3. And now I've solved for y. I also know opposite angles are the same, so k and m would match, j and l would match, so 2x is equal to 50. And when we divide by 2, we get x is 25. So here's another check-in for you to try. Pause now if you'd like. Answers are posted on Classroom. Another property is that if a quadrilateral is a parallelogram, then its diagonals bisect each other. So the whole diagonals aren't the same, right? PR looks much longer than QS is, but QS got split into 2 equal pieces, and PR got split into 2 equal pieces. So that will happen in every parallelogram. So let's continue. We know opposites match, so 27's here, 27's here, 18's here, 18's here. I also know the 2 pieces inside. These 2 pieces should both be 7. And then they told me RT, the entire other diagonal is 30. So if I split that 30 into 2 equal pieces, we get 15 and 15. So now UT, from U to T, I found was 27. From S to T was 18. From V to S was just 7. And then from V to T was 15. Another example we'll do together now focuses on the angles. So I know that the whole opposite angle equals the whole opposite angle. But I also know I have alternate interior angles here. So if this one's 21, this one's 21. If this one's 71, this one's 71. We also know angle FED. The whole angle here is 134. So if I take the 71 away, I can find the other side. So 134 minus 71 is 63. So I could put 63 there, and the whole thing was 134. If this whole thing was 134, this whole thing would be 180 minus 134, which is 46. So taking the 21 away from 46, I get 25 and 25. So now I have every angle in the corners. If I needed something with the G in the middle, I would be able to find that because I have triangles, but for right now, it's not necessary. So let's just answer these questions. D, E, C. If I traced D, E, C, that's just pointing to this corner with 63. So 63 degrees. For C, D, E. So C, D, E is talking about the whole angle over here, which was 46 degrees. E, C, D. If I trace E, C, D, it's pointing to the corner with the 71. And D, F, E, tracing D to F to E, is this corner here with the 25 degrees. This can get very confusing very quickly. So in this problem, we have it all. We have segments and we have angles. What I would recommend doing for a problem like this is focus on just one piece of the puzzle at a time. I'm going to focus on just the segments at first. So I'm going to fill in XY. XY was this side, was 15, so I could fill in 15 here as well. WX was 22, so I could fill in 22 here as well. ZX, the whole diagonal was 32, so cutting that in half would give me 16 and 16. And then WT was 10, so this is also 10. So looking at just the segments, ZW was 15, ZY was 22, TX is 16, and then WY, it's the whole diagonal, 10 plus 10 is 20. So what I'm going to do is I'm going to erase all my segment stuff because I want a fresh picture with only the angle information inside. So now angle WZY. WZY is this whole angle, so I'm going to put it on the outside, is 62 degrees. Already, I know this whole angle is 62 degrees. 180 minus 62. So we get 118. This whole angle is 118. This whole angle is 118. That was all from that one thing right there. Angle WXT, so WXT is just this little corner, that was 27. So I know this is also 27. 62 minus 27 is 35, and 35 are alternate interior angles. And then ZWT. ZWT is this part here, 77 degrees, so we can fill in the opposite, 77. And now 118 minus 77 is 41 degrees. So we have it all filled out. So one thing at a time. TZY. TZY. That points to the 27. X, Y, Z. That's the whole angle here at Y, so that's 118 degrees. X, W, T is pointing to the 41. And then X, Y, T is pointing to the 77. So here's a check-in for you to do. I would highly recommend trying it. Pause now and check your answers on Classroom. I would also recommend doing the segments separately from the angles, just like we did in example 5. We have one last problem to do, and that is a proof with parallelograms. So we are given that we have these two parallelograms. Next step, number 2, says AG is congruent to BC. So in parallelogram ABCG, those were opposite sides. And I said that they were congruent. So my reason in the proof could be opposite sides congruent in a parallelogram. I believe it was called the opposite sides theorem, parallelogram opposite sides theorem. If you want to call it that, you can. I find it easier to just describe what I was saying. The opposite sides are congruent in a parallelogram. Step 3 says that segment ED, which is here, is congruent to segment BC, which was here. So now we're talking about the other parallelogram, but it's still talking about the opposite sides. So I could use the same reason. Opposite sides congruent in a parallelogram. So my last step is I say that segment AG is congruent to segment ED. This bottom one here is congruent to this bottom one here. So they're not in the same shape. So I'm going to look at my proof, and I saw AG here, and I saw ED here, and they're linked together by the common segment BC. So when we're linking together, we're using the transitive property. And that is the end of section 7.2.